the business of it, just like you. I figured a perfect game to develop.
Hi guys. So today we're doing single replacement, but like I said, there's a little bit more to it. We're going to be assigning charges, or what are called oxidation numbers, to get ready to do oxidation reduction reactions. So you're going to do the same thing and double check to see whether or not, in this case, of course, iron is active enough to be able to replace copper. And when you look over here, we have iron and copper's way down here, so yes. So first off, you're just going to go ahead and write the reaction. So Fe is now going to be with the sulfate, and the copper is going to be by itself. So the copper is now solid, and the Fe is aqueous, and we'll just assume it's iron +2 and sulfur -2 for sake of ease. All right, so there's our single replacement reaction. It's balanced. Now what you're going to do is you're going to go ahead and you're going to assign charges to them, or oxidation numbers, and write our ion equation to get to a net ionic. So iron as a solid is just a solid piece of iron. It's an atom, so it doesn't have any charge. So that's going to be Fe0 with no charge. Then we have copper with +2, aqueous. Then we have sulfate with a -2, aqueous. Then we yield FeSO4 is aqueous. So we have Fe with a +2 and SO4 with a -2. So, sorry, I should backtrack. This is number 1 from single replacement reactions 1. Sorry, I forgot to say that. So I'm just writing these on the back because it's easier for me to do. All right, and then we have copper, and copper is a solid, so it just has a 0 charge. All right, so now we do the same thing. If anything is on the left and the right, we can consider it a spectator ion. So we have SO4 on this side and SO4 on this side, so we cross those out. So now we have Fe0 as a solid, copper +2 ion, and we're yielding an iron ion because now the iron is the one that's combined and the copper is kicked out and is by itself. And then we're going to do more with these after I get back, but for right now, that's where you're going to go ahead and stop. So that's going to be your net ionic to get us ready for redox. So you're going to do that with each one of them. This was like what we did the first day. So this is a metal replacement reaction. The second one, so I'm just on the same paper, number 2 now. So number 2, it looks kind of different because it has K and H2O. But if we write water as HOH, you can see that the K could replace the H. So this is a reaction with water. So they're all single replacement, but just different styles. So now we look to see if K is more active than H. So H is down here and K is up here, so way more active. So the K is going to replace that. So now the K is going to be with the OH, and that'll be aqueous. And the hydrogen got kicked out, and we know that hydrogen is always diatomic. And hydrogen wouldn't be a solid, that would be hydrogen gas. We'd see bubbles. So if I put potassium in water, basically I see bubbles. It's a reaction that takes place. As far as balancing, we need a 2 here. So that'll give us 4 H's, 2 there. That'll give us 4 H's, 2 O's, and then a 2 here. All right, so then as far as our ionic, so we have 2 K solid, so that's with a 0 charge. And then remember, this is a 2 HOH, really, we rewrote it. So this is 2 H pluses aqueous and 2 OH minus aqueous. Then that's going to yield 2 K plus aqueous and 2 OH minus aqueous, and then hydrogen gas, which is as one piece like a solid, so it's got a charge of 0. Spectator ions, we've got 2 OHs and 2 OHs, so our net is 2K0 plus 2H plus aqueous yields 2K plus aqueous plus H2O gas. Sorry, gas. Okay. And then the last one, same thing, HCl. So the zinc or the tin will hopefully replace the hydrogen, and this would be a reaction with an acid, single replacement. Okay, and same thing, you check whether tin was more active than hydrogen. If so, it would kick it out. And then same thing. So this is what I want you to do for each of the ones on this single replacement reactions number 1. So you have to write the reaction, write it in its ion form. The new piece really is that if something is uncombined, it has a charge of 0. Cross out your spectator and write your net ionic. Okay, and then turn that in. Thanks, bye.